Here's an alternate way of doing problem number 1. Two vectors lying in the xy plane are given by the equations a equal 5i plus 2j and b equal to 2i minus 3j. Value of a cross b is, if we use a cross b equal to the determinant, where we in our first row of our determinant we put I, j, k vectors, and in the second row we put the first vector coefficients. In front of the I we had a 2. In front of the J we had, a 5 for the A. In front of the J we had a 2 and no K, 0. For the B vector we had a 2, a negative 3, and 0. So that's our vector determinant. To evaluate this, let's repeat the first two columns and put them off to the right here. So we have IJ, and the values in those columns are 5, 2, 2, negative 3. To evaluate this determinant, we do our first three diagonals. This diagonal, plus this diagonal, plus this diagonal. And so that is going to equal I times 2 times 0, which is 0, plus j times 0 times 2, which is 0, plus k times 5 times a negative 3, which is a negative 15k. Then we subtract these other three diagonals, this one, and this one. From the first one, we're going to have a minus 2 times k, or 4k. Then we're going to have a minus negative 3 times 0 times I, which is 0. And then we're going to have a minus 0 times 5 times j, which is 0. Alright, so there we have it. A cross B is equal to a negative 15k minus 4k, which is a negative 19k. So there's an alternate way of solving problem number 1, and we end up using this cross product determinant, negative 19k, for our answer.